Hello everyone. My name is Satyavikram Pratap Singh. Hello everyone. My name is Satyavikram Pratap Singh. This is the 10th tutorial session of the Network Analysis course, whose instructor is Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur. I am Satyavikram Pratap Singh. I am a PMRF research scholar at Department of Energy Science and Engineering, IIT Bombay. So last class also we have discussed few of the things related to two-port network. And this class is also will talk about some of the problems which will help you to solve the tutorial means uh, problem solving, which was assessment of 11th module. And so before starting means, class, if you have any doubt, you can ask me while opening the mic, and also you can write in the chat box also. So we are starting the session. So this is the first problem before you. So try to solve it and let me know if you face any doubt related to that. If my voice is not clear, just let me know in the chat box, or you can open your mic as well. So few things which I have told in the last class that you have to remember that with what is the input parameters and what are the output parameters for the uh, different parameters basically. So suppose I'm talking about the input and output values of the things. Okay, let me. So, so before starting session, there are few parameters you should remember. Suppose I'm talking about this Z parameters, input and output side of that. Z parameters you have the Y parameters in place. You have ABCD parameters. Okay, you have this H parameter, and also you have the G parameter basically. So what are the input and output values for that? So in the Z parameter, that is V1, V2 here is equal to Z11, Z12, Z21, Z22 is times of, because these are the output value I1 and I2. Y parameters we have already seen that I1, I2 is equal to that. These things you have to remember that Y11, Y12, Y21 and Y22. These are the parameters, and V1 and V2. ABCD, that is the V1, I1, these are the input parameters, and in terms of what? In terms of the V2 and minus I2, because the current which is assumed ABCD parameter, that current is going out of the network. That's why it is kept as negative. So that is A, B, C, D. And the H parameter, if you talk about, it's a V1, I2 is equal to H11, H12, H21, H22 is equal to I1, V2. Okay. And for the G parameter, it's I1 V2 is equal to G11, G12, G21, G22 is equal to V1 I2. So these are the things which is important for solving the few of the problems. Okay. Solve the first problem. Okay, in front of you. Okay, let me give the solution for this first problem. Okay, so in the these are the parameters which actually we need, and you have to remember these formulas for solving the few of the problems. And for the Z parameter, from here, if you see, which we have seen in the last tutorial session also, how to proceed these kind of problems, basically. Okay. So the input parameter, if you see, these are the V1, V2 input parameters. The parameter which we need, Z11, Z12, Z21, and Z22. And these are the I1 and I2. Okay. So what we need? We need actually Z21. Z21, what is the value of Z21? Z21 is basically V2 by I1 and I2 is equal to 0. How we got? We have got from here. Let me take the another pen. This V2. This V2 in terms of I and Y2. If you expand it, it will be written as Z21 I1 So it could be written as Z21 I1 plus Z22 I2. Okay. So what we need? You need V2 by I1 basically, just this term. That's why the at I2 is equal to 0, you can get that parameters. Okay. Okay. So it means that I2 is equal to 0 in this term. It means that this port basically here, this side of port, take another pen, this side of port will be open circuited. It means that the current which is inducting from this port, it will be I2 is equal to 0. Why? Because this is the V2 and this is the V1 and this is the I1 basically, which is inducting into from the port 1. Okay. So this is the port 1 and this is the port 2. Okay. So now if you see here, in this terms, because the you need the I2 is equal to 0. It means that, suppose let me take it as, let me take another pen. Suppose I take it as I1 dash. Okay, so what current will flow from here? That is the I1 minus I1 dash. Okay, so the same current, because the I2 is 0, so the same current will flow come from here as well, the I1 minus I1 dash. Okay, so it will come out to be, how it could be written as? It could be written as V2 is equal to, because here if you add the both current, because in the if you apply the KCL here, it will come as the I1 will flow into this. So the V2 will be equal to I1 minus I1 dash multiplied by 2 plus 2 times of I1 here. Okay, it could be written as 4 times of I1 minus 2 times of I1 dash. Okay, and if you apply the KCL in this, if you apply the KVL in this loop, it will come out to be 2 times of, let me take another pen, 2 times of I1 minus I1 dash will be equal to 2 plus also, because this is the voltage drop across this and voltage drop across this. The 2 I1 equal to 4 times of I1 dash. So how you could be written as? It will be written as 4 times of I1 minus 4 times of I1 dash will be equal to 4 times of I1 dash. It will be equal to 4 times of I1 is equal to 8 times of I1 dash. I1 is equal to 2 times of I1 dash. Okay. So what we got? We have got the two equations basically. From here we have got the one equation. Here we got that second equation. Try to put the equation 2 into equation 1. You will get V2 is equal to 4 times of I1 minus 2 times of I1 dash. When you put it, you will get 4 times of I1. 2 times of I1 already equal to I1. It will be equal to 3 times of I1. So V2 by I1 is equal to 3 basically. Okay. The parameter which you got here, the Z21 basically equal to 3. So try to grasp Try to solve this. And if you're facing any doubt, just let me know. I will give the parameter values also so that it will be easy for you to understand and solve. Okay. In this problem, basically, it was saying that okay, you have this two-port network. This is the two-port network which is drawn like this. This is the one two-port network, that is network one, and you have the network two basically here, and you have this V3 here and the I3 which is going out, and you have this V2 in between, V2, and the current I2 is going out, and also from the input side, it is actually the AC source that is equal to V1 at the port 1, and the I1 current is injecting into the network. So, so this is basically the port 1, and this is the port 2, and this is the port 3 basically. Okay. And the equations for this, because it is written in the ABCD parameter form, so the V1 could be written like this, I1, V2, and I2 could be written as. Okay. So we have already seen the network theorems. So here also you have to find out the Thevenin equivalent at the port 3, which is consisting of the voltage source and the ZT parameter ZT. Okay. Try to solve this and let me know if you have any doubt. So this is the port 1, port 2, port 3, and you have to solve for the ZT and the VT. Okay. Just let me know if you have any doubt. Try to solve this problem and go step by step by the VT and then solve for the ZT basically. And for the Thevenin, basic terminology is like that. For the finding out the Thevenin voltage, just from where you are finding the Thevenin equivalent, basically the Thevenin voltage, you have to open circuit that port. Okay, it means that I3 you have to kept zero, and then solve the VT in terms of the V1 basically. Okay, some factor times of the V1. Okay, keeping I3 is equal to 0, because at that port, because that port number 3 you have to find out. So from where you can see, so the I3 will be kept at 0 because the it is open circuit port. Okay, try to solve it. Keeping the values in this equations basically, you can solve it. Okay, I'm solving this for the Thevenin voltage. Okay, so after that you could solve the for the Thevenin impedance basically. So let me solve for the Thevenin voltage from where you will get few of the idea. So the problem is easy. It's not that much conceptual, but there few understanding is needed because few of the basics. So what is asking here that there are the three ports. Here is the port 1, port 2, and port 3 is there. Listen here. So here the port 1, port 2, and port 3 is there. And the four equations basically of the three ports have been given. Okay. What are asking here? The Thevenin voltage. Okay. So the basic terminology of the Thevenin voltage is that the port from where you wanted to find it out the VT voltage. Okay. Here, what is the VT here? The V3. Okay. Here you wanted to find out the Thevenin voltage. At that moment, the I3 will become zero because that port will be open circuited, and you have to see from that terminal what is the value of VT basically. So if you see from here, if you see these equations, okay, so let me call it equation 1, equation 2, equation 3, and equation 4. Let me see the equation 4 first. If you see here, the I2 will be become is equal to C2 times of V3, and this I3 will become 0 because for the Thevenin voltage, this is open circuited, so that's why I3 will be equal to 0. What will become the equation 3? Equation 3 will become V2 is equal to A2 times of V3. Okay. So what we needed actually, we needed the V3 in terms of some factor times of the V1, which is equal to Thevenin voltage basically VT. Here it is written the VT connected in the series, and we need the Thevenin equivalent in terms of the V1 basically. Okay. So here also you can see the V1 values are given here. Okay. So if you see the how could we wanted to find out? So V1 is already we know. What is the equation from the equation 1? We already seen that okay, V1 is equal to A times of A1 times of V2 plus B1 times of I2. Okay. Okay. So what is the value of V2 basically? V2 we have already seen from here. So let me take another pen. So from here we got the V2 value. Try to put it here, and the same value of the I2, try to put it here. Okay. You will get in terms of another values. Okay. The A1 we have got, let me take the A1 we have got here. And what is the value of V2? V2 is actually the A2 V3 plus B1. And what is the value of I2? I2 is basically C2 V3. Okay. So the V1 could be written in terms of the V3. V3, how to write it? A1 A2 plus B1 C2 is equal to V3. And what is the value of V3 here? V3 is actually VT because the Thevenin voltage by keeping the I3 is equal to 0. So the V3 we have got V1 divided by A1 A2 plus B1 C2. Okay. So if you match the options also A, B, C, D, the fourth option is actually matching. There's D option. Okay. So it means that if you could find it out and also the B option, so from the B and C, you could eliminate the two options, the A and C. Okay. But you have to find the values of the ZT basically. Try to find out the value of ZT. ZT, let me give you one hint. For the ZT basically, the if you could remember that the voltage sources will be short circuited or it could be replaced with their internal impedances, and also the current sources will be also replaced by their internal impedances. If it is not given any internal impedances, it means that the voltage sources will be short circuited and the current sources would be open circuited. It means that from the port 1, if you see the port 1, you have the one voltage source here. So it means that you have to sort it out. Sorting means the V1 could be will be equal to 0. Try to fit it values, and what is the value of Z Thevenin? Z Thevenin will be equal to V3 by I3 by keeping the V1 is equal to 0. Try to find out this value, you will get the answer. Okay. Try to solve for the Thevenin voltage. Take your time and let me know if you have any doubt. Okay, let me give the solution for this problem. I hope you are solving that problem, and let me give the some hints and some of the solution for this. Okay, listen here. For finding out the Thevenin equivalent, which I have also shown that the Thevenin voltage will be equal to from this port, because the port 3 you have to see. It means that V3 by I3 and all the voltage sources which are there into the system and will be actually short circuited or open circuited based upon their nature. Okay. Okay, no problem. It's a part of learning. So it's a this kind of a step by step you will learn the things. So there is no need to worry about that. And after solving these problems, you should solve it also once again so that it can be kept in your mind. Okay. So the Thevenin voltage basically the this is the V3 by V3, and by keeping the V1 is equal to 0, because all the voltage sources which are there, the voltage sources will be short circuited and the current sources will be basically open circuited. Okay, or it will be replaced by the internal impedances if it is given. Okay, so let me assume that this is the equation 1, this is equation 2, this is equation 3, and this is the equation 4. Okay, so before moving that, we have kept the V1 is equal to 0. It means that if you see the equation 1, okay, what we have kept? We have kept the V1 is equal to 0, which is equal to A1 V1, A1 V2 plus V1 times of I2. Okay, and if you see the second equation, that is equal to equation 2 basically, that is equal to I1 is equal to C1 V2 plus D1 I2. Okay, so, and also what we needed basically the ratio of the P3 by I3, okay, by keeping the V1 is equal to 0. If you see the equation number third, and you will see that there is a term of V3 and I3, A2 V3 and plus B2 I3, okay. So in this equation, in the equation 3, if I could able to find it out the value of V2 in terms of V3 or I3, it will be able easy for us to generate the equations basically. Okay, because we already know the value of V2. Okay, V2 is equal to V3 I3. Okay, so if I get the value of V2 in terms of V3 I3, so that will be easy for you to get the ratio of the V3 by I3. Okay, so if you see the values from here, if you see here in this equation, basically, so it is equal to V2 is equal to basically minus V1 I2 divided by A1 basically, and is equal to A2 V3 plus B2 I3. Okay, and if you see the equation number of 4, there also the I2 equation is there. Okay, so it means that B1 by A1, by keeping the equation of this equation number 4 into this, okay, in this at this the value of at the value of I2 from the equation 4 basically, you will get the values of the V3 in terms of the V3 and I3 basically. So it will be equal to C2 times of V3 plus D2 times of I3 is equal to A2 times of V3 plus B2 times of I3. Okay. Now the each terms, if you could see in terms of the V3 and I3 basically. So divided by the I3 all side, what you will get? You will get minus B1 by A1. Okay. C2 V3 by V1 plus D2 is equal to A2 V3 by I3. Sorry, I3 basically. We have divided by I3. V3 by I3 plus B2. Okay. Now we already needed what we needed? We needed this ratios only. Okay. If you could rearrange it, let me rearrange this side. If you could rearrange, what you will get, let's assume that this is the ratio K. Okay, it will be easy for an understanding. V3 by I3 is actually K basically. So what is the value of K? If you rearrange, K will be equal to A2 A2 from here we got A2 plus B1 C2 by A1, okay, is equal to B2 plus B1 here D2 divided by A1. Okay. What is be the ratio it will become A1 B2 plus B1 D2 because we are taking the A1 as a LCM. So this part will go into the denominator. So it will come here. It will be equal to A2 A1 plus B1 C2. Okay. Let me explain once again. Let me have explain once again. It will be easy for understanding. So initially what we have seen, we needed the ratio of the V3 by I3 by keeping the V1 is equal to 0. It means that V1 we wanted to short circuit it. So what we have done, because the equation of V1 is there in the first part. So what we have done, we have kept 0 is equal to A1 V2 is equal to B1 I2. And we also seen the equation number of 3. Equation number of 3 is already having the in terms of the V3 and I3. And we wanted to put the values in terms of the V3 and I3 also in terms of. So what we have done from the equation 1, what we have taken here, uh, this part, this equation 1, what we have kept it here. Okay. So in the place of V2. So it become minus B1 I2 by A1. Okay. This value only from the here. From here itself, we have kept it here at the value of V3, basically here. So it become A2 V3 plus B2 I3. Now we have kept the equation number of 4 because it is in the terms of the I2. I2 in terms of the V3 and I3. So we have kept the value of I2 which was equal to C2 V3 plus D1 I3. What we have got? We have got all the equation terms of the V3 and I3. Here also V3, I3, V3 and I3. What we have done? We have divided by I3. So here we have got the ratio of the V3 and I3. We have assumed that it is equal to K. Then what we have done? We have rearranged it. So here is the rearranged part is there. So the K and this A2 here, this is the A2, and this part, this B1, A1, and C2, we have kept here the V1, C2, A1, and then we have kept the other side that is the B2, basically this part, and then D2, B1, A1 part here. Okay, then we have rewritten it. So K is all equal to A1, B2 plus B1, D2 is equal to A2, A1, and B1, C2, basically. Okay, so we have already got the C and D options were correct. So now we have got the JT also. Now the answer number D is actually correct. Okay. Any doubt in this? If you have any doubt, just let me know. Okay. 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 Fine. That's cool. I haven't done the algebra one. That's fine. That's fine. Okay. No need to worry about that. Okay. Try to solve it once again. After that, we will see if you have any doubt. Okay. Try to solve this problem. Let me give one hint here that you already having the one Z matrix here, the P, the Z matrix of this P is equal to Z11, Z12, Z21, and Z22 basically. So what they have done, they have added one ohm resistor in series, okay, in series to this two port network, okay. Then you have to find it out if you add the one element in series how this Z matrix will be transformed. Okay, now you have to find out new Z matrix, Z new. Okay, this was the Z pole. Okay, by adding 1 ohm series impedance, what will be the value of Z new? Okay, try to solve. So the option D I have got that option. Let me see the chat box. Option D actually I have got. Okay. Okay, let me solve it. Okay. Let's see that whether it is correct or not. And after that we will see what is actually the correct value. Okay. So let us go with the basics. Basics is that we already know what is the value of two-port network, which we knew that Z old. What is the Z old basically? That is equal to Z11, Z12, and Z21 and Z22. Okay, and that input values. Let me erase this. What will be the value of input values? Input values are basically V1, V2 is equal to I1, I2. Okay. So if you see in this question, what they have done, from the input side, if you see here, from the port 1 only, the input side only will be affected, not the output side. Why? Because they have connected this input impedances because they are the actually the values which is basically a constant values. So that's why if you see from the input side, they have added one series impedance basically at the input port side. Okay. So the output word will not get affected by this. Okay. So let me assume few things here. Let me assume few things. Let me erase this. Okay. So this is basically the two-port network. Okay. And this was the added part, that is the 1 ohm. And this was initial V1 value. Was the V1 and the I1 current which was going here. And this port was actually the V2 and the I2 current was coming into system. Okay. So now what is the new value? New value is equal to V1 dash. Okay. And the output part will not be affected. There is no voltage terms will coming into the change value. So this is actually the two port. So if you see what is the value of V1 dash? V1 dash is basically equal to V1 because the I1 current is flowing into this here like this. So the current I1 is flowing like this. So that's why the V1 is equal to V1 plus what is the added terms? It's equal to I1 multiplied by 1, which is equal to V1 plus I1. Okay. And we already having the two equations from this matrix, basically this matrix that will be equal to V1 is equal to Z11 I1 plus Z12 I2. Okay. So this is the first equation, equation number one. And what is the second equation? V2 is equal to Z21 I1 plus Z22 I2. Okay, so this is basically the second equation. And the third equation which we have got here. Try to put the value of the V1 because the V1 is actually the new term here. V1 dash is the new term. So what we wanted to find it out the value of in terms of the V1 dash. That's why we will get the overall picture. Why? Because now the new matrix will be formed like this. V1 dash V2 is equal to new Z new in terms of the V2 I2 because the V2 I2 will not be affected, so they are same parameters, but only the V1 terms will be get affected. Okay, try to put the value of V1. This put the value of V1 because V1 in terms from equation 3 to equation 1. Okay, when you keep what we will get, you will get it initial. What was the initial? V1 is equal to Z11 I1 plus Z12 I2. Try to put the value, we will get V1 dash minus I1. Okay, from this equation. From this equation, okay, you will get what is the value of V1 here? V1 is equal to V1 dash minus I1. So we will keep it here like this. Is equal to Z11 I1 plus Z12 I2. Rearrange, you will get V1 dash is equal to I1 1 plus Z11 plus Z12 times of I2. Okay. Now, if you see that the second equation, if you see the equation number two, second equation, that will be affected. Why? Because the all the values which is being affected is actually the V1 value, and the I1 value will not be affected because they are in the series. Series, the I1 same current is flowing from the V1 dash also through the V1 also. So that will not get changed. That's why the overall matrix how it will form the Z new Z new will be formed like this. It will be equal to 1 plus Z11, Z12, which from here is this equation, and also the second will be the Z21 and Z22. So the option C will come as a correct value. Okay. Any doubt in this? From where we have moved? From where this was the old value. Let me take another pen here. So this was the old basically. We have added the V1 here is we have added one series resistance here 1 ohm. So it will become V1 dash here because now we need the Z new. Z new, what is the Z new? Z new will be the this whole system. Okay. So what will the affected value? The affected value will be the V1 basically. So now it will come V1, which is equal to V1 plus I1 times of 1 ohm, which will become V1 plus I1. Okay. And the old equation, what was the old equation? That was the V1 is equal to Z11 I1 and V2 is equal to Z22 I2. So what we have done, we have kept the equation 3 value into the equation 1. It became V1 dash minus I1 from this equation here it will become Z11 I1, Z12 I2. So now we have rearranged, so it will become V1 dash is equal to I1 1 plus Z11, Z12 I2. So now the Z new matrix, because the other two second equation will not be get affected. That's why we will get the 1 plus Z11, Z12, Z21, Z22. Okay. Any doubt in this? Any doubt? Okay, fine. So this is the basic funda that, and also remember it. Remember why I'm saying that there are few things which if you can memorize or it will be easy to understand and solve the other problems as well. Okay. So just remember that when you are adding one series resistance in series with the Z matrix, so it will be Z11 value will be affected and it will become Z11 plus Z dash which you are adding. Okay, only the Z11 value will be affected. Okay, let me give the second kind of problem probably on the same manner basically. Try to solve this problem. This is the Z11 here. The Z11 here it is given as Z11, okay, given as 40 ohm, and Z12 is given as 60 ohm, and Z21 is given as 80 ohm, and the Z22 value is given as 100 ohm. Because what is the Z old basically? The 40, 60, 80, and 100. And also the average power delivered across the RL. This is the RL which is equal to 20 ohm. You have to find out the value of the what is the average power which is being delivered through this RL. Okay. So this is the Z matrix. So this is the V1 basically here, V1, and this is the input current I1, and this is the plus minus, and the plus minus here, this is the V2 and the I2 current injected into this. Okay. Just remember that what we have seen in the next last problem that Z new will be equal to Z11 will be affected Z dash and Z12, Z21, Z22 will be the same. Okay. This will be Z new. You can, this is a part of hint. Okay. Try to solve it and let me know if you have any doubt. And also the thing is, what is the value of power, average power? Average power is equal to I2 square times of RL. Okay, that is a kind of also a hint. If you feel any doubt or you need any hint, just let me know. Okay. And here you can use this thing. So we have got three unknown and the equation. Okay. That's why you need. Let me solve this. Okay. That kind of problems is actually very important. Let me solve it, and after you could solve it again at your home. Okay. So let me solve it and observe the problems and this kind of problems how it could be solved. Okay. So if you see here, and what is the equation basically? What we needed? We needed the power, average power. This is our requirement, and this which is equal to I2 square RL. Okay, this is basically equal to I2 square RL. Okay, what we need? We need the value of I2. Value of I2. That is our important and the basic requirement basically. Okay, and the second thing is that this I2 is actually equal to V2. If you see the V2, this V2 is equal to minus I2 times of RL. Okay, because the current is going out of this system. So that's why, and this is the voltage here V2, and this is equal to V2 is equal to minus I2 RL. Okay, RL basically, which is equal to minus times of 20 times of I2. Okay, uh, we needed I2, we got the V2 in terms of V2. What is the value of Z new? Z new, which from the last problem we have seen, which is equal to V1 dash, V1 dash, V2 is equal to Z11 plus Z dash, Z12, Z21, Z22 is equal to V2 I2. Okay. Here you will get two equations, one equation here, second equation here. What we got? Let me solve it. What is the value of V1 dash? Let me solve it here. Okay. What is the value of V1 dash? V1 dash is given here 20. 20 volt it is already given. Okay. This is the V1 dash. So the 20 is equal to V1 dash is equal to what is the value of Z11 plus Z dash? It will be equal to 40 was already given. So it will become 50 basically. Okay. 50 times of I1, V1, V2, and this is the I1 basically. Let me erase this. So this is the value is equal to V1, V2, I1 and I2. Okay. 50 times of I1 plus Z12. Z12 is already given. This is 60. 60 times of I2. We have got one equation. Second, what is the value of second equation? The second equation is equal to V2. V2 what we have found out? V2 we have got minus 20 times of I2. Keep it here minus 20 times of I2 is equal to Z21. Z21 is already given 80. 80 times of I1 plus 100 times of I2. Okay. Now, if you could see, you got the three questions. Let me see here. This was the miss 4 5 equations basically. This is the equation one, which is already here. This is the equation one, and this is equation two, and this is the equation three. Okay. If you could solve this first equation one and equation two, you could get the value of I2. Okay. Let me solve it. This is equal to 80 times of I1 is equal to 120 times of I2, which is equal to 2 times of I1 is equal to 3 times of I2. Okay. If you see the equation 1, which is equal to 20 times of 20 is equal to 50 times of I1. I1 we don't need, we need the value of I2. So it will become 2 by 3 times of I2 from this equation basically plus 60 times of I2. What is the value of I2 you will get? You will get I2 is as equal to 60 divided by 100 plus 60. It will become 6 divided by 16. That will equal to 2, 8, 16. 3 by 8 basically. It is correct. 2 I1 is equal to 3 times of I2. So the I1 is equal to 3 by 2 basically. Sorry. 3 by 2 here. This will be 3 by 2. It will become 20 to 40. So it will become 40 here and 150 here. Okay. So let me erase this. Maybe and solve it again. So the I2 will become 50 here. I2 will be become 2040 divided by 150 plus 60 is equal to 4 divided by 21 basically. Okay, 21. Is it correct? That is equal to 20 is equal to 50 times of I1. I1 is equal to 3 by 2 times of I2 and 60 times of I2. So the I2 will become 20 to a 40, and this also become 120 here. So this is also incorrect. So it will become 150 plus 120. That will become 40 divided by 0 here, and this 7, and this will be 270. That will become 4 by 27, I think. Okay. This will become 150 plus 120. That will become 270 and 40. Okay, that's correct. Okay. So what is the value of power average? Average power will become I2 square times of RL. What is the value of I2? I2 is 4 by 27 of square will be equal to multiplied by RL, 20. The important point here is to remember that if you have, let me take it here. So if you are having the two-port network and you have this input impedance added in between the system, that is the V2 and this is the I2, and this was the V1 basically, and then this is the I1, and the Z dash was added and the V dash it became. So now the equation will be like this: V dash V2 will be equal to, let me take V1 dash is equal to Z11 plus Z dash Z12 Z21 Z22, okay, is equal to I1 I2. This is the first thing. Second important thing is that if you are having the impedances attached to the output side. Suppose this is RL and this is the V1 and V2. Suppose this is the V1 and the I1 current is entering, and this is the V2 and the I2 current is entering here. Now in this kind of forms, you have to keep the V2 is equal to minus I2 times of RL depending upon the where the current is being taken. It is into the system or the output of the system. Okay. So this is the two-port network. So you have to keep the value here. This V2 is equal to minus I2 times of RL. So that's how you will get the value of the different equations basically, because you having the three variables and you have need the three equations as well. So from here you will get the third equation basically by keeping it here. Okay, any doubt in this? Any doubt in this problem? Okay, that's fine. So this is how the this kind of problems could be solved. Okay, that you need the value of the third equation by keeping the value of the V2 in terms of the RL. Okay. Try to solve this problem. This is also a kind of similar problem, and try to solve it. Here one hint is that use the y parameter. Okay, y parameter and the second equation of that is equal to I1 I2 is equal to y11 y12 y21 y22 is equal to v1 v2. Use the second equation of that. This part, this values. Okay, that is equal to I2 is equal to y21 v1 plus y22 v2. That will make you understand and it'll be easy to is kind of new to you, just let me know, okay? So that I can make you understand this kind of sets, basically. Okay, okay. Try to solve. Okay, let me explain this problem. Okay, that's good that you have attempted it. That's very important that you should not lose hope and try to solve and attempt the every problem, whichever way you wanted to understand it, the concept. Okay, let me explain this problem. If you see in this problem, what is saying that if you read it, the linear two-port network, when 10 volt is applied at the port 1, a current of 4 ampere flows through the port 2 when it is short circuited. What is saying that? Okay, let me take these statements and try to bifurcate it. Okay, till here, till this. Okay, it could be represented like this. Suppose you're having the two-port network and you're having this here, the voltages and all. So what is saying that when 10 volt is applied at the port 1, it means that I have applied 10 volt here, okay, and a current of 4 ampere flows through the port 2. It means that the 4 ampere flowing through it like this, okay. The standard representation is like that. Okay, current is going into the ports, okay. Here also this will be I1 and the 2 4 port here. When it is short circuited, it means that this port is actually like this, short circuited, okay. So if you see that here, what we got the what we have told that you should use the y parameter basically that is equal to I1 I2 is equal to y11 y12 y21 y22 which is equal to v1 v2. Okay, so if you consider this second part, this part basically, so you can represent it like this kind of problems that I2 basically is equal to y21 v1 plus y22 v2. Okay. And if from here, from the statements, it is saying that it is short circuited from the secondary side. So here it is got short circuited. It means that v2 is equal to 0 and the I2, the current which is flowing from the output side is actually the 4 amps. Okay, so what we have got? We have got the Y21 and the V1 which we have applied here is the 10 volt because the 10 volt is applied here. From here we have got the Y21 value which is equal to 10 by 10, 4 by 10 that is equal to zero point 0.4. Okay, that is the important meaning for the first statement, first part of this paragraph. Let me take the second part. Second part means from here till here. Okay. If you bifurcate it and see this second part of the paragraph, what is it written? Let me take another side. It is written that you're having the two-port network here. This is the two-port network. And when the 5 volt is applied at the port 1, it means that the 5 volt have been applied here, this 5 volt. And it is saying that the 1.25 current flows through the 1 ohm resistance connected across the port 2. It means that load side they have connected the 1 ohm resistor and the current which is flowing across it is equal to 1.25 amps. Okay, it means that across this is also used. Important point is it is flowing through the 1 ohm resistor. Through means it is flowing like this. Okay, the current this I2 is flowing like this into the system. What was the standard convention? In standard convention is like this. Standard convention should be like this. That current is going into the port. Now here what is given that the current is actually flowing across the 1 ohm resistor. Okay. Now what you have to take the I2 as a negative value. Okay. Let me take the another equation that is same equation, this equation basically here. I2 is equal to y21 v1 plus y22 v2. Okay. What is the value of I2 here? I2 is already given. It is the value is equal to 1.25 amps from the second part of this paragraph. Okay. And the I2 value is equal to 1.25 amps. That is fine. And the Y21 we have already find it out. What is the value? Zero point 0.4. What is the V1 which we have applied? It is a 5 volt. Okay. Plus Y22. What is the value of V2? That is the same thing which I have explained here. If you're having the resistance at the output side, you can represent this like this. V2 is equal to minus I2 Rn. Okay. So here also V2 is equal to, here this is the V2 basically. V2 is equal to basically plus I2. Okay. That is not flowing out of the network. That is equal to I2 times of. It means opposite side. So that's why they are equal to minus I2. So standard convention of this minus I2 is basically this. Standard convention is like this, I2 here, like this. But here the I2 is negative, which is coming across it. So it means that it will be I2 times of R, which is equal to minus I2. And the I2 value is already we know, which is equal to 1.25. Okay. So how to solve this? If you see this, this is 1.5, this is actually the 2.0. So it will become minus 0.75 here will be equal to minus y22 minus 1.25. So what will be the value of y22 will be equal to 75.75 divided by 1.25. When you solve, you will get 25 threes and 4 5. It will become equal to zero point 0.8 basically. So we have got the two equations basically, or two values, the y21 and y22. What we have got basically, we have got y21 value and y22 value. Okay, we have got the two values. Now let's read the third part of this paragraph. Okay, what we have read. This is the first part we have read till here, and the second part till here. Let's read the third part from here to here. Means this part. What is saying that if you apply the 3 volt, so if you are having the 2 volt here, if you apply the 3 volt at the port input side, this is the 3 volt here. The current through the 2 ohm resistor connected across the port 2. It means that it is saying that the 2 ohm resistor. Okay, you got zero point 0.6. Okay, let me find out. Then we will re-verify whether it is correct or not. That's good that you have got the answer. Okay, so let me re-verify whether it is correct or not. Okay, so let's solve it. So we have got that V1 is equal to 3 is equal to Y21 value. What is the value of Y21? That we have got the zero point 0.4 basically. Zero point 0.4 times of V1. V1, what is the value of V1? It is 3 plus what is the value of Y22? That is zero point 0.8. What we need basically the current across the 2 ohm. The current is equal to here and V2. V2 will be equal to minus times of I2 and multiplied by 2 basically the V2. Let's find it out. 3 is equal to 4 theta 12. It is equal to 1.2 minus basically 2 I2 zero point 0.8. What will be the value of I2 we will get? We will get 1.8 here divided by 1.6 basically, and it will be equal to, it is correct or not. Let me recheck it. Let me recheck it, and let me take another color. So it means that if 3 is equal to basically I2 no, I2 will be equal to I2 here, that's it. I2 is equal to I2 and the zero point 0.4 times of V1, V1 is 3 plus minus I2, 2 times of I2 here and multiplied by zero point 0.8. Okay, so I2 will be get added here. It will become 1.6, 2.6 here. It will be equal to here 1.2. So I2 will be equal to 12 divided by 26, 6 divided by 13, I think. Uh, can you re-verify whether it is correct or not? The I2 we have got here I2 and zero point 0.4 from here, and 3 is actually the V1 which we have applied here, and the minus 2 times of I2 because the I2 is assumed to be flowing into the system. So that's why it is equal to, and the 2 ohm. So that's why minus 2 I2, and we have got the zero point 0.8. So I2 here, when you add it, you will get 1.6, that is here 2.6, and it is equal to 1.2. 12 divided by 26. So that's why 2, 6, 12, and this 13 here. Okay. Any doubt in this? 6 by 13, I think, correct. You can re-verify at your home, but the major funda is that this kind of problem could be solved in bifurcating the problems into the different parts and different chunks, basically. Okay. Okay, that's good. That's good. Okay. So let's move to the next problem. Try to solve this. This is easy kind of problem, and take your time. And if you need any formula, just let me know. Let me give the H and G formulas basically, and after that you can solve. Z you already know. H is basically V1 I2 is equal to H11 H12 H21 H22 is equal to I1 V2. These are the input and output value for the G, which is actually equal to I1 V2 is equal to G11, G12, G21, G22 is equal to V1 I2. And you know the already the value of the I1 Z1 Z2, that is V1 V2 is equal to Z11 Z12 Z22 Z21 basically, and Z22, and is equal to V1 V2, and here I1 I2. Okay, let me know whether which option is actually correct. If you need any hint, there also you can let me know. Okay. Okay, let me give some hint for this. Hint is that if you see this is the open circuit for this is the input side, and this is the output side. Okay, if you see that this is already open circuited, it means that I1 is nowhere it is going to be zero. Means all the time it will be equal to zero only. Okay, I1 is already equal to zero. And the V2, if you see, the V2 is already being equal to zero. Why? Because the output side is already being sorted. Okay, take it as a hint that I1 will be always will be equal to zero and V2 will be always equal to zero. Okay, verify whether which options is actually matching with this. Okay, which parameters basically. Okay, let me solve this. Okay, C is the okay. You called it. Actually, that is correct. C is the correct answer. Okay, so the way it could be solved that easily means it will kind of and what is actually needed. If you see that the what is the easy way to go through that Z parameter. Z parameter is always been easy for solving. Okay, so the Z parameter is basically V1 V2 is equal to I1 I2. So if here I could have gone through this Z1 Z21 and Z22 because the V2 is already being 0. It means that Z21 will be equal to 0 and Z22 will be equal to 0. And what about the Z11? Z11 and Z12? Z11 will come out to be infinite, okay, because the I1 was 0, okay. So the option D and option A will be ruled out, okay. Let's check the H parameters. H parameter, what is the input and variables? That is the V1, I1 is equal to H11, H12, S21, S22 is equal to output variables are V1, V1 not I1. H parameter is V1 I2 here. V1 I2 and this is the I1 V2. So we have already know that ki I1 and V2 is equal to 0. Okay. It means that the all the values will come out to be infinite. Why? Because in the all the parameter, if I could go through the H11, that will be equal to V1 by I1. Okay, that is the value at V2 is equal to 0. V2 is equal to 0 satisfying, but I1 is equal will be there, so it will come out to be infinite. Okay, so the H parameter is actually not S. What about the G parameters? G parameter input variables are I1 V2 is equal to G11, G12, G21, G22 is equal to, and the output variables are V1, I2. Okay. If could I have taken that G11 especially, that is equal to I1 by V1 at I2 is equal to 0. Here the I1 is already being equal to 0. That will be 0. If you take the G12, that will be also 0. If you take the G21, G21 is basically V2 by V1 at I2 is equal to 0. Here the V2 is already being 0. So that's why it is 0. If you take the G22, it will also come out to be 0. That's why the C option is actually correct. Okay. Try to solve this problem. One hint here, one hint in this kind of problems that always remember that if the some impedance is connected in series, kind of this only one impedance Z1 is here, so it's a T parameter. Basically, ABCD parameter will be given like this: 1, Z1, 0, 1. Okay, remember this. That is most important thing. If this is a circuit one, second is like this. If the it is in the vertical sense, suppose this is the Z1, could be given like this. So its ABCD parameter will be equal to 1, 0, y, 1. What is the value of y here? Y will be equal to 1 by Z1 basically. Okay, consider this is the hint. And the third is that if you are having the two ABCD parameters, two ports, suppose like this, okay, A1, B1, C1, D1, and second is the A2, B2, C2, D2. If you multiply, means they are in the cascade formation, you can multiply it. Means equivalent will be become like this: A1, B1, C1, D1 multiplied by A2, B2, C2, D2. Okay, you can multiply the both the and you will get the final values. Okay, so these are the three hints you can incorporate in this problem. Okay, whichever will be applicable. This is the equivalent ABCD parameter. Just multiply both matrix. C. Okay. Okay. Try to solve it, and after that we will see whether how to solve. Okay. Okay, I got the answer as option B. That's actually correct. Option B is correct. Okay. So let me give the solution for this problem. That is similar manner that 1z01, you already got this is the 1z01 and it could be multiplied. So, but we have got equivalent like this 1, z1, 0, 1, and the second was equal to 1, 0, 1 by z2 and divide this will be equal. When you multiply, you will get the equivalent like this 1 plus z1 by z2. This will be equal to z1 and this will be equal to 1 by z2 and this will become 1. Okay. So the value of the C was already given. It is equal to 0.025 angle 45 degree, which is equal to 1 by z2. So z2, what will be the value of z2? Z2 will become 1 divided by 0.025 angle 45 degree. It will come out to be 40 angle minus 45 degree. Hmm. Okay, that's correct. Okay. Let's solve the another set of problems that is equal to this. Okay, that is this was actually the statement base only. So the for the transmission matrix for the reciprocal basically for the reciprocal this mod of t is equal to 0. Okay, this is a kind of memory based problem. So you don't have and also if it could be of that symmetry for the T kind of matrix, it will be equal to A is equal to D. Okay. So, and mod of T means basically mod of A, B, C, D is equal to 0, which is equal to AD minus BC equal to 0. Okay. This is a kind of memory based problem. You don't have to solve and go into the depth. Try to solve this problem. And one hint for this also, if you are having the you if it could be asked that the Z matrix. Okay, and it is in the T-shaped format. Suppose this is the Z1 and this is given at Z2 and this is given at Z3. Okay, this is a kind of T-shape. Okay, and what is the Z matrix of this? Z matrix will be simply equal to the of means diagonal element will be summation of that. This is Z1, Z3. You have to sum it like this. And what is the value of Z22? Z22 basically equal to Z2 plus Z3. And of diagonal element, just write the value which is there in the vertical direction. That is Z3, Z3. Okay. This is the one hint. Try to solve it. Okay, 3. 3 is actually correct. That is the correct answer. So simpler way to solve that, that is equal to ZB is being asked. So this, if you see the ZA plus ZC will become 2J omega, and the ZC we already know means basically ZC this is equal to J omega. So from here you will get ZA, ZA will become Z omega, and ZB which means this Z2 plus Z3. This is basically equal to ZP plus ZC will become 3 plus 2J omega. Okay. From here you will get ZB. ZB will become 3 plus J omega. So the real part of it will become 3. That is correct. Okay. 3 is the correct answer. Let's move to the another set of problems like this. Okay. So this will be the last problem and try to solve it. And we will share few of the problems which you can solve at your home. And after this tutorial session, we will discuss whether it is if you have any doubt. This is the last problem of the today's session. Okay, D. Okay. Okay, let's go to the step by step and try to verify whether it is correct or not. Let's first see the Z1 one. Okay. What is basic definition of Z1? Finding the Z1 that is equal to V1 by I1 at V2 is equal to 0 because the V1 is equal to basically Z11 I1 plus Z12 I2. Okay. What is the value of Z11? You will get when you keep the I2 is equal to 0. Here the I2 is equal to 0. So it means that when you have to open circuit while finding out the value of Z11. Okay, so keep it this port, this output side port as open circuit. Okay, it means that there will be no current flowing from the output side. So let's take that. Let's take this as a I1 value current flowing into the system. So this is the I1 current flowing into this. And if you see this, it will be get bifurcated. Let's take that this is the I1 dash and this as a I1 minus I1 dash. Okay. Let's try to apply the KVL. KVL in this loop basically. Try to apply the KVL in this loop. Okay. Try to apply the KVL in this path basically. So it will become the V1 because this is the input side, this is the V1 and this is the V2. So V1 will become they're simply equal to 6 times of I1 minus I1 dash. Okay. So this is the simple set. Okay. Now apply the KVL in this path, second path. Just take the other path here in this path basically. Okay. What you will get? You will get simply like this. The V1 or you can make the loop also. Let's take the loop only. It will be easy. Let's take this loop, basically this loop. Okay, so this is a kind of closed loop. So let's try to find out the value. So simply 3 times of I1 dash when you are moving from this side like this. Okay, like this. 3 times of I1 and here also the current which is going here because no current coming from this is also equal to I1 minus I1 dash and simply it will flow like this and here it will go into also I1. Okay, so that will be equal to I1 dash basically. So I1 dash, so this is equal to I1 dash minus I1 dash basically. Okay, so this is equal to 3 times of I1 that is simply equal to I1 6 times of I1 minus I1 dash. Okay, try to rearrange this and you will get 3 times of I1 dash basically and 6 times of and I1 and the I2 is equal to 0, 6 times of I1 minus I2. You will get this 3 I1 dash is equal to 2 times of I1 minus 2 times of I1 dash. That is simply equal to 3 times of I1 dash is equal to 2 times of I1. When you keep it there, this will become 6 times of I1 minus I1 dash. I1 dash is 2 by 3 times of I1. So it will come out to be V1 is equal to 3 by 2, basically 6 by 3 times of I1. You will get V1 by I1 is equal to 2. So it means that A and B option is currently actually matching. You can solve it by taking the Z12 value, this second option. If it is coming negative, then you can solve it and get. So simply you can do like this V1 by I2 at I1 is equal to 0. Now what you have to do? You have to open circuit the second path. Okay, and then see the what is the value of V2. Okay, and the correct answer will come out to be option A. Okay, any doubt in this? You can solve it at your home. That is simply that what the process I followed. You can simply that follow the same procedure and you will get the answer. Okay, any doubt in this? Okay, so that's all for the today's session. I will share this slide and go through once and try to solve the problems as much as problem as because all the variety I have kept in this two-port network slide. Okay, there are few more problems are there which is also important. Is like this kind of problems and this kind of problems. Okay, try to solve it by yourself because the time is actually running away. So if you feel any doubt, just let me know in the other tutorial session. Okay, that's all for the today and have a good day.